All right, so here we are with units and measurement. Okay, it's kind of the basis for physics. It gives everything we do kind of a purpose, helps us stay neat and clean and straightforward. Without units, we'd kind of be lost children. We wouldn't know what is going on. So it's important that we do this, and this is kind of the basis for our day. So what are they? What are units? They give numbers meaning. They make numbers worthwhile. Number never becomes just a number. It becomes something, a purpose. Gives it a drive in life. You take the example. If I tell you I'll be back in 5, what does that even mean to you? How do you know when I'm going to be back? Is it going to be in 5 minutes, seconds, hours, years, decades, centuries? You have no idea whatsoever when I'll be back. You assume probably 5 minutes because that's what everybody else assumes. And because we say, hey, take 5, Hollywood and things, and that's 5 minutes. But you could mean 5 hours. And if you said meant 5 hours and someone didn't mean that, they thought you meant 5 minutes, there's confusion. Um, and it might cause some serious heartache in your friendship with somebody else. So it's important that you give numbers units because then everyone knows what's going on, everyone knows what it is, everyone knows what's going on. Very straightforward. Uh, okay, you never know when that guy's coming back. Look at him; he's just lost. So in physics, you got to keep track of them. You have to keep track of units because units give you all sorts of benefits if you keep track of them. And if you don't keep track of them, they will hurt you. They will come back and haunt you in your dreams. Okay. First, they let you know what you're dealing with. Am I dealing with acceleration, velocity, time, position, energy? What am I dealing with here? They help you keep track of the correct answer. Are you trying to get, is your correct answer supposed to be in meters per second, miles per hour, joules, kilojoules? What is it? Who knows? But it helps you keep track of that. And you can use them to help check your equations. If you think your equation is just some falsified thing, if it doesn't give you the units that it should give you, that equation isn't real. Okay, and this is one of the main things. If you can solve an equation just using units, you're going to be pretty successful in this class and in any science class you ever take. We have two systems of measurement pretty much. We have our old English system, we have the metric system. Okay, and for distance, we're very familiar with this in America. We measure things in inches, feet, yards, miles. They make sense to us. We're used to them. We know that there's 5,280 feet in a mile. That's just kind of some random number. I don't know how they came up with it, pulled it out of a hat or something, but we're used to that. Okay, but in the metric system, we use meters, and then we just add a word before, whether it's kilometer, millimeter, centimeter, and we know things increase by 10, and it makes sense. I'm talking to you. Meters aren't going to make that much sense to you. You're not used to them. Okay, they're confusing. However, they are nice and neat, and that's the system we're going to use here in physics. Yards, inches, feet, they're not nice and neat. They're kind of confusing if you really get down to the basics of it. And this is kind of how these systems we're going to see. The Old English system is going to be very confusing. The metric system will be very nice and neat once you get to know it. For example, cups, quarts, and gallons. Okay, I mean, what do we have here? In the metric system, we have the liter. Okay, we have Fahrenheit in the Old English system. It doesn't make much sense in Fahrenheit. What temperature does water freeze? Well, 32. Well, why is it 32? It's just one of those things that it doesn't make much sense. Okay, however, Celsius, when does water freeze? 0. When does it boil? 100. So you know a nice, neat, clean system moving by tens. Time, seconds, minutes, hours is the same in the metric system. That is one of those ones that we've based off the revolution of the sun, and this kind of gives us a nice thing and universal. And although it may seem kind of confusing, at least it's somewhat significant. Mass. Okay, we don't measure your mass in pounds. That is different. It's slugs. And you've probably never heard of slugs. Okay, but that's what we measure mass in. We never really measure mass in the Old English system because no one uses slugs. But the metric system, we use grams, and we love grams. Once again, it's just like meters and liters. You just kilometers, kiloliters, kilograms, We know what those are. They all kind of make sense to us. Force, however, is pounds. So pounds is a measure of force. It isn't a measure of mass like we think it is. And that'll come into play a lot more when we start talking about Newton's laws. But force is pounds. And in the metric system, we measure it in newtons. Okay? If you're famous and you invent something or you discover something, you can name something after yourself. So the way we measure force is in newtons. Okay? Wonderful little comic here. You run 10 yards out, curl a few feet to the right, and I'll hit you. No can do. Why not? He refuses to use things like that. It's kind of one of those things that's, I find hilarious. This is kind of a big deal. This is what I mean by keeping track of your units. NASA lost $125 million Mars orbiter because one engineering team used metric units while one used English units for a key spacecraft operation. And things didn't get converted right because they thought one was here, one was there, and it got lost. Okay, so it's important that you know what your units are so that everybody's on the same page. All right, so you remember we were talking about meters and liters and grams, and all I said to do to change it was just to put a word in front of it, and that's exactly what this is. If you look right here, you have milli, centi, deci, deca, hecto, kilo, mega, giga. Okay, these are all words that you'd stick in front of meter. So you could say hectometer, decameter, decimeter, centimeter, millimeter, micrometer, nanometer. And those all give something else. So we talked about meter as in terms of measuring distance. So I can measure distance in nanometers. I can measure them in kilometers. I can measure them in gigameters. Okay, I can measure mass the same way. I can measure mass in just grams, centigrams, micrograms, picograms, and I could measure liters the same way. Okay, the big deal is what do we need to measure? For example, if I want to figure out how far it is from Salt Lake City to Denver, I probably don't want to measure that in centimeters or millimeters. They would just be way too much. We know a centimeter is not too big, and a millimeter is about the thickness of a dime. I do not want to figure out how many millimeters it is from here to, or from Salt Lake City to Denver. I however, would use something bigger. Could I use meters? Yes, I could. It would still be a big number, but it would be more manageable than millimeters. I would probably rather use kilometers, and that's exactly what we do. We call those kilometers or kilometers. Either way is fine with me. You take, that tells us, oh, it's, 700 or 300 or whatever it is. That's a more manageable number than, let's say, 4 million of something else. If we went to mega, it could be a lot more, and so on. And as you see this is what we find. If we talk about 1 kilometer, that means there's 1,000 meters there. In 1 hectometer, there's 100 meters. In 1 decameter, there's 10 meters. If you have, there are 0.1 meters in 1 decimeter. There is 0.01 meters in 1 centimeter. And that makes sense, right? This is to the hundredth. This decimal point's to the hundredth. And 100 is a century. So a century is 100 years. Centi kind of gives us to the 100. A millennia is 1,000 years. Milli, so you see where we kind of get in these words. I just put that in front. So millimeters, I would have to get 1,000 millimeters to make 1 meter. Okay, and those are the kind of things. And we have this little stepstone here that we can follow. Okay, if the meter's here, and you go up 1, 2, 3, that's up 3, so that's 3,000, or that's 1,000 meters and 1 kilometer. If we go down, then you go backwards, right? So there's 0.1 decimeters, or 0.1 meters in 1 decimeter. There's 0.01 meters in 1 centimeter. But it still works going this way. So if I'm at millimeters and I'm going up 1, 2, 3, that means there's 1,000 millimeters in 1 meter. If I go up 1, there's 10 millimeters in 1 centimeter. Okay, let's do a practice. So if we look here, we've got our little stepper over here to help us out, and we want to take from meters and go into kilometers. So how many meters are there in 24 kilometers? Okay, so we can start here, meters, and we're going up to kilometers. We're going up 1, 2, 3 steps. That's 3 zeros. So you can either add 3 zeros onto the end because we know we're going to need more meters since the kilometer is much bigger than a meter. Or we can times, because we're going up, we can times by 1,000 because that went up 3, so 3 zeros is 1,000 to get our answer. And so if we do that, we end up being 24,000 meters. You could also just move the decimal point. We know the decimal point is here. We're going up, so it's going to get a bigger number. We can go 1, 2, 3, and that's what we see here is going 1, 2, 3, 24,000 meters. Okay. Now, let's go to number 2. How many grams are there in 36 milligrams? Well, if we have grams here in place of our meters, which is exactly the same, this is just our base unit, so that could be liters there. But these words do not change. Okay, so if we have grams here, how many grams are there in 36 milligrams? We notice we're going down 1, 2, 3. So if we're going down, we either need to move the decimal point opposite, so we need to move it to the left, or we need to divide by 1,000, because we went down 3 spots, which is 3 zeros, so that's 1,000. So if you do that, let's just move the decimal point here. 1, 2, and 3, so we got to add a 0 in there, so it's 0.036 grams. And that's what we see happening. Okay, now if we go to the last one, how many milliseconds are there in 3 hectoseconds? This is kind of conversion we probably won't use too much. We don't really use hectoseconds. We'll use hecto for other things, but we really don't use them for seconds. Milliseconds, however, we will use. Okay, so we're starting here at milli, and we're going up to hecto, so that's up 1, 2, 3, 4, 5. Okay, so we can, we talked about going up. We can either add 5 zeros onto the end of this 3. We can times by whether 5 zeros is, which is 100,000. So we could do 100,000 times 3. Or we could just move the decimal places 5 spots this way. Which if we do that, let's add 5 zeros on the end. That gives us 300,000 milliseconds. Okay, if we were going backwards, if we wanted to figure out how many hectoseconds there are in 3 milliseconds, we'd go down. We do the same thing. We just go backwards. Okay, and that's the same thing. Now the last question is kind of a confusing one, and this is one that's kind of stumpy. If we talk about number 4, how many milligrams are there in 8 decimeters? Now some of us will be like, okay, we got deci and we've got milli, and we're here in meters, so deci to milli, we're going down 2. That means we're going to move the decimal point backwards a little bit over here in milli and going up. Before you get all confused and you look at things, notice something that there's different about this question than the other 3. Notice here that this says meters and meters. Here it's grams and grams. Here it's seconds and seconds. Here it's grams and meters. Here I'm asking you to convert grams, which is mass, into distance. That isn't possible. That is just confusing. We don't know what that is. Okay, so we've got to make sure that those are the same. Okay, and that comes with just practice, making sure, being thorough, taking your time. Okay. Now, here's the big problem. Can you add this up? Can you add 12 feet, 3 yards, and 24 inches? I mean, if we did that, we could come up with something outrageous like 39 feet, yard, inches. Well, what the heck is a feet, yard, inch? Nobody even knows, okay? That can only result in this. Explosion, destruction, everything else, okay? You must convert units. I have to change these units into something that I can work with. Okay, so I can change all of these into feet. I can change all of these into yards. I can change all of these into inches. It doesn't really matter. I could change them all into miles. But they all have to be in the same unit in order to add them up. Okay, so I know that, for example, 3 yards is 9 feet. There's 3 feet in a yard, so 3 times 3 is 9. I know that 24 inches is 2 feet because there's 12 inches in a foot. And now I have 9 feet, 2 feet, and I know that 12 feet is still the same. So 12 plus 9 plus 2 gives me 23 feet. Much simpler, much more concise, much prettier, much more understandable than our monstrosity over here of 39 feet yard inches. All right, so let's talk about the train track method here. This is one of the methods we use, and one specifically that I use to convert units into something else. For example, we have up here 13.1 miles, okay, and we want to get that into inches, okay. Most of us can't really calculate in our head how many miles or how many inches are in a mile. That's kind of a very big number. None of us deal with that on a regular basis. We don't really need to know. Okay, so, but in physics, we have a lot of things we need to convert. Sometimes you're given miles and you need meters or something like that. And so this is the way to do it. I still convert units this way because it's still, no matter what you do, it'll come out right. Okay, if you follow these steps, you won't get lost or make a mistake or forget something. Okay, now there are two rules. The first one, always start with what you've been given. And the last one is map your way to the unit you want. Okay, so the very first thing is this. We draw our train tracks. These are what we call train tracks. And you start with what you've been given. So in this case, we were given 13.1 miles. Okay, so we start with that, and that always goes up here in the top left-hand box. So there's our 13.1 miles. Okay, the next thing is map your way to the unit you want. We want inches. So we are going to keep mapping until we get to inches. Now, we do know that when something's on the top and the bottom of a fraction, it can cancel. So for example, I'm just going to take this miles here and put it down here on the bottom of the fraction. If I do that, miles will cancel, and they disappear. Okay, that unit's gone, and I can convert it into something else. So I automatically put my miles here. Now, I don't know the direct conversion factor for miles into inches. However, I do know miles into feet. Okay, so I will put feet up here because I do know that 1 mile is the same as 5,280 feet. That is the same number. 1 mile equals 5,280 feet. So they go on top of each other because they're equal to each other. Okay, this is like timesing by 1. Okay. Then I don't really want feet yet. I am trying to map my way to inches. I got to get rid of feet somehow. So I will automatically put it down here on the bottom. By doing that, that'll top and bottom, I can cancel those units. I can cancel these units and get to the ones I want. Now, I do know how many inches are in a foot. Okay, I do know that for every foot there are 12 inches. That's a conversion I do know. So by doing it this way, I've got to the unit I want. I understood the things that I needed. Okay, so then I just fill in the numbers here. Okay, I know that 1 mile is the same as 5,280 feet, and that 1 foot is the same as 12 inches. See how these are the exact same measurement? You need to have them the same. Okay, it could be anything. We could say 4 cups are a gallon. 16 ounces is a pound. Okay, any of those things will work. They equal each other. 16 ounces and 1 pound are exactly the same. 60 minutes and 1 hour, they're exactly the same. Okay, you can use those interchangeably, so they have to be the same here. Okay, now sometimes I'll use made-up units, but I'll tell you what equals what. All right, so then we can do this. Watch how these will disappear. Okay, so those miles disappear because they're on top and bottom. The number does not disappear, but the unit does. Okay, and 5,000 and feet go away. I'm left with only inches on the top, which is exactly what I wanted here in the problem. That was the unit that I wanted. Now, I'll just do this like a normal fraction. So I'll times over all the top numbers, and then I'll times over all the bottom numbers. Then I'll divide those two. So I'll go 13.1 times 5,280 times 12 will give me a number. And then it'll be 1 times 1, and I'll divide those. Now, I do know that 1 times 1 is 1, and anything 1 on the bottom of fraction is okay. So 13.1 times 5,280 times 12 is, in fact, 830,016 inches. Okay. We can, this is a practice for you if you want to pause this and practice, see how tall you are in meters. In ears, now this is one that people always kind of complain about. How tall are you in ears? Well, you got to know how big an ear is. One way is just to measure it. Okay, measure an ear. If your ear is 2 inches tall, or you want to do how many ears wide you are, I mean, that's the same idea. Okay, you'll just have to convert it. Now, The big thing about doing how tall you are into meters is most of us refer to us as how many feet in inches. If I ask how tall you are, most of you are going to say something like, I'm 5'8". What does 5'8" actually mean? 5'8" actually means I am 5 feet 8 inches. Now if we go back to that, you can't do those together. You've got to convert 5 feet into inches, or you've got to convert 8 inches into feet. Preferably, it's probably easier just to do feet into inches because you can't just say zero point 0.8 inches or zero point 0.8 is in feet there. Okay, so these are some practice problems you could do. Another one, the new field is 1.6 miles long. What would that be in kilometers? Once again, we start with what we know. So we're going to start with 1.6 miles, and we're going to map our way into what we want, which is kilometers. Okay, so I've done that here. I started with miles. I didn't know straight miles into kilometers. Some of you, we might eventually get there, but at the moment I don't. I do know miles into feet, and I did know feet into inches. So see how they're all right there? I did know inches into centimeters, and centimeters into meters, and meters into kilometers. So this one's kind of a long one. But as you notice, miles on top and bottom, they can cancel. Feet on top and bottom, they can cancel. Inches on top and bottom, they can cancel. Centimeters on top and bottom, they can cancel. Meters on top and bottom, they can cancel. Kilometers is the only thing not canceled, and that is exactly what we want. Okay, so I can also do things like, I could put the numbers in here. 1 mile is 5,280 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. 100 centimeters is 1 meter. 1,000 meters is 1 kilometer. And then I'll times over, and divide, and it comes out to be 2.57 kilometers. Okay. Now, double conversions are ones that are the same, however, they look completely different. They look very, very confusing. Okay. Just take a deep breath. They are the same. There's only one extra rule, and that's this big star here. You convert the top unit first and then worry about the bottom. So in this case, we are given 15 meters per second, and I want to get into miles per hour. Okay, so if I bring up my train tracks and I put this out here, okay, realize that this big bar here is just a division bar. So 15 meters goes on the top because 15 meters is on the top of the fraction. Realize that this divide sign is just a fraction, and seconds is on the bottom of that fraction. So seconds will be on the bottom here. 15 meters on the top, seconds on the bottom. Now, if I don't put anything in front of this, this would be 1 second, right? We say 15 meters per 1 second, or 15 meters every second is how fast I'm going. So every second that passes, I'm going 15 meters. Okay, so that's how it is right here. Now, let's not worry about the bottom unit for right now. We won't worry about seconds. We just want to convert the top unit. So if I go over to my question here, I need to map my way to my unit I want. I notice that miles is the unit that is on top. Miles per hour. Miles is the one that is on top. Okay, so I want to get to miles. So first thing I'm going to do is I'm going to move meters down. Okay, I do know meters to feet. That is something I do know. So I'll go meters into feet. And I do know feet. So I don't want feet yet, I want miles. So I'm going to put feet down here. And then I do know feet into miles. So notice now that if I cancel here, I'm only left with miles. Okay, and I know that 1 foot or 1 meter is 3.28 feet. And 1 mile is 5,280 feet. And if I do it, the meters cancel. Feet is also on top and bottom, so they cancel. I'm left with miles on top, which is exactly what I wanted for my top unit. So the top unit is done. Okay. Now let's worry about the bottom unit. Here I am with seconds. I actually want to get my bottom unit into hours. Okay, so since the seconds on the bottom here, the only way to get rid of it, to cancel it out, is to have one on the top. Notice top and bottom, same sort of pattern. If it's on the bottom here, I do need to put it on the top. So I'll just put my seconds up here. Now it doesn't matter that they're not next to each other, but it just kind of helps me keep track of things if I do this first, then worry about this other one. Okay, we worry about the bottom unit. So now that seconds are on the bottom and the top, they can cancel and go away. And I would be left with no seconds, or nothing on no unit on the bottom. Okay, but I do want a unit on the bottom. and I want hours. I do know how many seconds are in a minute, so I can put minutes here. Now I got to get rid of minutes, so it's got to go back to the top. So see how the bottom unit and the first and the top unit, they're just switched. I went from top to bottom here. Here I'm just going bottom to top, but it's the same idea and the same principle. Okay, so I got minutes to minutes. Now I know how many minutes are in an hour. That I do know. Now if I put this in here, I know that 1 minute, there's 60 seconds there. In 1 hour, there is 60 minutes. Okay, I can cancel. Notice that the seconds and the seconds went away. There's one on the top, one on the bottom. Okay, minutes, one on top right here, one on the bottom here. And hours doesn't have anything to cancel with, so it's the only thing left. So my bottom unit is hours. And that's exactly what I wanted. I wanted miles on top, hours on the bottom, which was what I have. I can just do the same thing that I used to do. I can go 15 times 3.8, 28 times 1 times 60 times 60 gives me a number, times over 1 times 5,280 times 1 times 1. Divide those two numbers out, and I would actually come up with 33.5 miles per hour. Okay, so double conversion is just the same thing twice. And one of them you have to worry about what's on top and what's on bottom. Okay, now you can do this practice problem. If you want to do the practice problem, go ahead and pause and then play it afterwards, and the answer will show up. I'm not going to show you any work here, okay, but that's how it works. So if you want to do it, go ahead and pause. Okay, so the answer to this one should be 0.62 or 0.63 liters per second. You do first convert gallons into liters, and then you'd convert minutes into seconds, and it would come out to be that number. Okay.